Now we are going to see the zero power factor method or Portier triangle method. This method is based on the separation of XL, that is the armature leakage reactance, and XAR, that is the reactance due to armature reaction. The armature leakage reactance XL is also called Portier reactance. Hence, this method is also called Portier reactance method. To determine this XL and XAR separately, we need to perform two tests. First one is the open circuit test, and the second one is the zero power factor test. We have already uh, studied the open circuit test and how to draw the open circuit characteristics in EMF method. Now we are going to see the zero power factor test. For zero power factor test, this is the field winding of the alternator, and this is the armature winding. Here, the field winding is provided with the DC excitation, and also here a rheostat is there, variable resistance, an ammeter to measure the field current, the armature winding for zero power factor test. We are having an ammeter to measure the armature current and the voltmeter, and here we are having a purely inductive load is connected across the TPSD switch. Inductive load. Variable load is there. This is the inductive load. To conduct this zero power factor method or zero power factor test, the switch should be the TPSC should be kept closed, and then this purely inductive load is connected to the alternator armature. This purely inductive load has a power factor 0, that is cos phi is 90-degree lagging. Hence it is called, this inductive load has power factors 90-degree lagging, that is purely inductive, so it is called zero power factor test. And here by adjusting the excitation, that is the DC supply using this rheostat, and the inductive load, the load current is maintained, that is the armature current is maintained at full load value, and the voltage also should be at the rated voltage. This condition, find out the field current corresponding to that. IF corresponding to rated current, rated armature current, and rated voltage. This is by adjusting the excitation and the inductive load. This is the procedure for zero power factor test. From the zero power factor test, we got the readings of the field current corresponding to rated armature current and rated voltage. First, we should draw the open circuit characteristics. The procedure for Portier triangle, drawing the Portier triangle is, first we need to draw the open circuit characteristics. Open circuit characteristics, that is the graph between IF and V phase. This is the OCC, open circuit characteristics. Next, we need to find the excitation corresponding to the rated short circuit current. That is, we got from the short circuit characteristics. That point is marked as A. This is the field current corresponding to rated short circuit current. This is A. That is, at that time voltage will be 0. Rated short circuit current, short circuit test, this voltage will be 0. And next we need to mark a point P. That P is the field current corresponding to the our Portier test. That is a P we are obtaining from the Portier test. That is the point at rated voltage when the alternator is delivering full load current and zero power factor lagging. That we obtain from that field current corresponding to the rated voltage we obtain from the Portier test. That point is P. Joining this A and B, we can draw a characteristics that is about parallel to your open circuit characteristics. Then draw a tangent to OCC through the origin, that is the line OB. OB is the tangent to OCC through the origin. That is also called the air line or air gap line or air line. That is OB. Okay. Then draw a line parallel to OA and equal to OA. OA to parallel and equal to the distance OA, that is PQ from P. That is P. This PQ value of PQ, the magnitude of PQ should be equal to OA and that line should be parallel to OA. Then from Q, draw a line parallel to this air line which intersects OCC at point C. Parallel to airline, you need to draw a line parallel to airline. That line can be drawn using sets parallel lines. So this point is taken as R. That parallel line intersects OCC at a point R. This should be parallel to this airline. My line, it is not this parallel line. So I draw this somewhat. Then join RQ and join RQ and then join PR. This triangle PQR is called Portier triangle. This triangle is called Portier triangle. From point O, drop a line perpendicular to PQ. Okay, that meet PQ at a point S. This is the perpendicular. Meet the point PQ at point S. Okay, this perpendicular line RS gives the voltage drop due to armature leakage reactance. We know the voltage drop due to armature leakage reactance is IA into XL. This IA into XL is the length of RS. So XL, from this XL or XL phase can be found out by per phase value, can be found out by length of RS divided by IA. That is a full load current. This is how from the Portier triangle we can find out the armature leakage reactance. Here the length of PS, that gives the field current necessary to overcome the demagnetizing effect of armature reaction at full load. PS, demagnetizing effect of armature reaction at full load. Okay, thank you. We can continue the ZP of mother in next video. Thank you.